So white light is incident perpendicularly on a thin oil film on glass. The indices of refraction of air, oil, and glass are all given right here in the diagram. You observe the film appears green, which corresponds to a wavelength of 520 nanometers. So in part A, at which of the interfaces does the light change phase? Well, the light changes phase whenever it reflects off from a low index reflecting off a higher index. So there's two reflections here. The first reflection occurs from the top layer, so it's the air reflecting off the oil, and then the second reflection occurs, the air enters the oil and it reflects off the glass. And you see in both cases, it's reflecting off something of a higher index, because air has an index of 1.0, and oil has 1.4, so because you're reflecting off a higher index, it's going to change the phase. And then once you enter the oil, which is 1.4, you're reflecting off glass, which is a higher index than oil, so that's also going to change phase. So the answer to part A is to check the box that says both interfaces. For part B, calculate the minimum thickness of the oil film so that the green light is the most intense. So the equation for thin film is 2T is equal to m times lambda n. Lambda n is the wavelength within the film, in this case within the oil, which is lambda divided by n, and m is just an integer value. It's an integer when you're talking about bright spots, or a half integer when you're talking about dark spots. Unless there's one phase change, it reverses, and if there's two phase changes, as there is in this case, it reverses again back to how it was. So the equation is 2t equals m lambda over n, and we want to solve this for t, so just divide both sides by 2. So the minimum thickness is going to be when m is equal to 1. So 1, and then times the wavelength, which was 520, we'll leave it in units of nanometers, divided by 2 times the index of refraction. This is of what the light has entered, which is the oil. So we want to do the index of refraction of 1.4. When you plug all this in for the thickness, the minimum thickness you're going to need is 185.7 nanometers. For part C, as the angle of the light source is adjusted, the light you observe from the film changes color. Give an explanation for why that happens. So in other words, you can take this light and start aiming it maybe like this angle, like that, and then instead of going through a thickness of 2t, because you're going through the film of thickness t and then back, you're actually going a little bit longer. You're going like this and like this, so that distance is a little bit bigger than 2t. So with this equation, the 2t is equal to m lambda over n. If this thing is essentially changing, that is going to change the wavelength. So since the t changes, that means the wavelength changes, and that's why you end up getting different colors of light. And then for part D, suppose that the oil had an index of refraction equal to 1.6 instead of 1.4. So this number right here is going to be changing. Calculate the new minimum thickness of the oil so that the green light is most intense. So we're going to go back to this same equation, which is the 2t equals m lambda over n, and still divide both sides by the 2 to get the thickness. So most people just make the mistake of just plugging in, instead of the n being 1.4, they just plug in the n of 1.6 and go from there. The problem is now that by changing the oil so that the index of refraction is greater than the glass, there's only going to be one phase change. The light's going to change phase when it reflects off the top, because you're going from low to high, which is 1.0 to 1.6. But in the next layer, it's reflecting from 1.6 to 1.5. There's going to be no phase change there. So that means the conditions for constructive and destructive interference are reversed. So to get the constructive interference, to get the intense green light, the m, instead of being the lowest possible integer value, is now going to have to be the lowest possible half integer value, which is 0.5. So 0.5 times 520 nanometers divided by 2 times the new index of refraction of oil, which is 1.6, and from that you get an answer of 81.25 nanometers as the thickness.